Hello and welcome. Today we're diving deep into something we see every single day but maybe don't fully understand: light. And we're going to unpack a model of reality that might just completely change how you think about the world around you and even about electric charge itself. Ready? Let's get into it.
So let's start right here, right now. Just ask yourself, what is actually allowing you to see this screen? And yeah, the obvious answer is light, right? But what if I told you that's really only half the story?
Because it turns out that what we call light is so much more. It's our personal window into an entire channel, a whole layer of reality that makes everything we see, everything we touch, everything we build possible.
To get our heads around this, we're going to use a model that looks at reality as 5 distinct channels of wave energy. You can picture them like stacked layers, and each layer is in charge of a completely different aspect of our universe.
So here are the 5 channels. K1, that's the channel for matter, physical stuff. And then there's K2 for electromagnetism, and that is going to be our star player today. The others, K3, K4, and K5, they handle bigger picture things like heat and even cosmic patterns. But for now, just lock this in. K2 is the channel for light.
Now, a really cool way to think about this stack is something called the softness ladder. K2, with its super high frequencies, is considered the hardest, most intense channel. But as you go down the list toward K5, the channels get softer. All that means is they operate at lower, slower frequencies and create these larger, smoother patterns in the universe.
But like I said, today we're zooming right in on that hardest channel, the one responsible for every single photon of light in the entire universe. Let's really explore K2, the seeing layer.
And this quote it nails the idea perfectly. K1 is the solid matter you can actually touch. K3 is what you feel as heat, that collective vibration. But K2? K2 is the channel you see. It's light, it's the signal, it's the information.
So K2 is the electromagnetic channel. Simple as that. It's what carries light and radio waves and X-rays. But it does something even more important. It's the force that allows particles of matter to talk to each other, to bind together. Seriously, without K2, matter would just be silent, dark, and invisible.
And this is where things get really, really cool. This model completely reframes something we all learned about in high school science: electric charge. It suggests charge isn't a property a particle has, but it's actually just a relationship between waves.
The source material puts it so elegantly. Charge is a phase choice. This is a huge idea. It means the difference between a positive charge and a negative charge isn't about adding some magical property. It's just about how 2 waves line up. Let me actually show you what this looks like.
Okay, so check this out. For an electron, which we all know has a negative charge, you have 2 waves. You have its core matter wave, that's K1, and its electromagnetic wave, K2. And look, they start their cycle perfectly in phase, perfectly lined up. According to this model, that alignment is what we perceive as negative charge. It's not a thing, it's a relationship. So then, what about a positive charge, like in a positron? Well, look closely. It is the exact same 2 waves, K1 and K2. Nothing new has been added or taken away. The only difference is that they now start perfectly out of phase. They're flipped. That tiny shift in their relationship is the entire difference between negative and positive. How simple is that?
Let that just sink in for a second. Charge isn't some little property that's glued onto a particle. This model says it's something that just emerges from the way the matter wave and the electromagnetic wave are dancing together. It's all about their alignment.
All right, so now that our brains are a little bit rewired about what charge even is, let's pull back and just appreciate all the ways this K2 channel shows up in our world. Because trust me, it is absolutely everywhere.
The entire electromagnetic spectrum, every single bit of it, is just K2 vibrating at a different frequency. Radio waves bringing music to your car, microwaves heating up your lunch, the Wi-Fi signal you're probably using right now, the visible light you're seeing with, even those intense gamma rays from deep space, it's all K2, just K2.
So when you see the bright color of a neon sign, that's just atoms spitting out K2 photons at a very specific frequency. And yeah, the signal that's bringing this whole explainer to your screen right now, that is K2 doing its thing. It's basically the great communicator of the entire universe.
So what is the big takeaway here? What's the point of all this? It's that some of the deepest, most fundamental parts of our reality might boil down to something really simple and beautiful. the elegant logic of waves interacting with each other.
Let's just try to put it all together in one sentence. K2 gives us light and charge, not as things, but as pure wave logic. Photons of light are just pure K2 waves, and all of matter can exist and interact because its K1 core is locked into this very precise dance with K2.
And that, of course, leaves us with one last, really fascinating question to chew on. If a concept as basic and fundamental as electric charge can be explained so simply, so elegantly, as just a relationship between two waves, what other giant mysteries of the universe are just waiting for us to realize that they, too, are just a different kind of dance?